Okay. So today we're going to talk about graphing, and then tomorrow your sub-assignment is solving exponential equations. And everything we're doing today is a review from Algebra 2, so I think it should go pretty quick. So first thing first, who remembers AH and K from Algebra 1 and Algebra 2? Okay, A stretches and compresses, H goes left and right, K moves up and down. Let's talk about where do you find this in an equation. When we're talking about an exponential equation, for an exponential equation, the A value is always in front of the base. The H is in your exponent, and you always flip the sign. And then K can either be in the back or in the front. So on your notes at the very top where it says horizontal asymptote at, go ahead and fill this in. You always have a horizontal asymptote at y equals K. So y equals K is your horizontal asymptote. Your domain will never change. All exponential functions have the same domain. It's all real numbers. The range is going to change though. If A is positive, it's K to infinity. So if A is positive, we're going to use K to infinity. But whenever it reflects down, because A is negative, we use negative infinity to K. So that's the only thing. Make sure you all have that copied down. I have the steps to graph right under where it says 5.3 notes. I already put these steps in. You don't need to copy it down. I think the easiest way to graph an exponential is to create a parent table using the base and then apply your transformations. Okay, and then apply your transformations. All right, so now that we have all the little logistics done, let's jump in and get it started. We're going to do 4 examples together. So let's look at example 1. I like to start by stating AH and K. So in this example, I'm going to do A, B, H, and K actually. In this example, your A value is the number in front of the base. Your base is what is attached to your exponent. The base has to be positive. So in this example, the base is 2. The A value is in front of 2. It's invisible. So when you don't see a number, that means it is 1. There is an invisible 1 in front of that 2. H is in your exponent, but you always change the sign. So it's not -3, it would be +3. And K is the number that's added to the back. And there isn't a number back here, or sometimes it's in the front. In your book, sometimes they put K in the front, but it will have a plus or a minus sign. And in this example, K is 0. So let's start off by let's fill in our domain range. We're not going to do y-intercept, so you can cross that out. So our domain does not change. That's the 1 point we should all get next week on the quiz. And my horizontal asymptote is at y equals K, so I'm going to put that y equals 0. I do have color pencils on the table if you want to use a different color, but I'm going to go ahead and draw in our asymptote. So drawing your asymptote at y equals 0, which is just your x-axis. Remember, an asymptote is a line that the graph approaches, but it does not cross. And I think to keep it simple, when I make my table for the base, which is y equals 2 to the x, I'm going to use the same 5 numbers. -1, 0, 1, 2, and 3. So in your calculator, type in 2 to the -1, and exponential means it's a changing exponent. So I'm keeping my base the same, and I'm changing my exponent. So type in your calculator 2 to the power of -1, 2 to the power of 0, 2 to the first, 2 to the second, and 2 to the third. Find your 5 y values. So you're typing in your calculator, you're changing the exponent. The base is staying 2. So what you're typing in your calculator is 2 to the -1, 2 to the 0, 2 to the first, 2 to the second, 2 to the third. That's what you're typing in. So 2 to the -1, we'll just write that as a decimal, 0.5. Anything to the power of 0 is 1. Anything to the power of 1 is itself. You should know that 2 squared is 2 times 2, and 2 times 2 is. And 2 to the third is 2 times 2 times 2, and 2 times 2 times 2 is 8. All right, so now we're going to apply our transformations. When you apply your transformations, it's always h plus x, y times a plus k. Who remembers this? Going back to algebra 2. Okay, so in this example, h is 3. So you're going to add 3 all the way down to these 5 numbers. Go ahead and add 3 to these 5 numbers. We're making a second table. The green table is the one we're going to actually graph. So let's start with that. So 3 minus 1. Hopefully we don't need a calculator for 3 minus 1. 3 plus 0. 3 plus 1. 3 plus 2. 3 plus 3. Go ahead and write your new 5 numbers. And for your y value, a is 1, so we're going to multiply these numbers by 1 and add 0. If I multiply by 1 and add 0, does that change the value of that number? No. So our 5 y values are going to remain the same. 0.5, 1, 2, 4, 8. This is the table that you're going to graph. Go ahead and graph these tables, these points, these 5 ordered pairs over here. So plot these 5 points over here. Put a point at 2.5, 3, 1, 4, 2, 5, 4, and 6, 8. It should look like a backwards L. That's really the best way to describe it, I think. So that's what your graph should look like. Keep in mind that it's not going through your asymptote. Now, because A is positive, your range is K to infinity. And K is 0, so it would be 0 to infinity. 0 does not get a bracket because it will never equal 0. It'll be really close. It might be 0.000000001, but you will never get an actual 0. And that's why we don't put a bracket. We use parentheses, and that's it. That is all that's to graphing an exponential. All right, any questions about how we did that first one? Okay, let's go to example 2. So again, I like to write my A, B, H, and K. So A is, B is. So I kind of like to just have that all labeled out. A is the number in front, which in this example is 1/2. What's the base of my exponent?
3.
Just 3. H is in the exponent and you flip the sign. So it's not +2, it would be -2. Your K value in this example is -7. So we already know our domain. I'm going to fill that in. We know our range, but I always do that last. Your horizontal asymptote is at y equals -7. So let's pick up your highlighter, color pencil, draw in a horizontal line at -7. So you're going to use the same values for x. So to keep it simple. And this time, because your base is 3, you're using your calculator and typing in 3 to the -1, 3 to the 0, 3 to the first, 3 to the second, 3 to the third. You might know these numbers without a calculator, but that's what you're actually going to type in your calculator. So go ahead and type those in to get your 5 y values. So type 3 to the power of -1, 3 to the power of 0, 3 to the first, 3 squared, 3 to the third. And we can just write it as a decimal. So 3 to the -1 is 1/3, but I just write it as 0.3 because I think it's easier for you to use a decimal. 3 to the 0 is 1, 3, 9, and 27. So now you're going to apply your transformations, and that would be h plus x, y times a plus k. So h is -2, so I'm going to add -2 all the way down. And then for my y's, I'm multiplying it by 1/2, which I'm going to write as a decimal. And then I'm adding -7, or you could just say subtracting 7. All right, so you're going to pick up your calculators and get your new table. And notice when I write the equation for my asymptote, I don't just put -7. I'm writing it as an equation, and that's what you have to do on the test. Y equals -7. And then it's a decimal. You're just doing the best you can to plot a decimal. It's impossible to do it perfectly by hand. You should just notice that your Y values are increasing slowly, and then they increase fast. So it looks like a backwards L. That's kind of what I look at. I don't know how to describe the shape of an exponential. It's approaching, it starts off really close to the asymptote, and then it goes up really, really slow, and then it rises up super fast. So the lowest Y value is -7. It's never going to be -7 though. So that's why -7 gets a parentheses, and it's increasing to positive infinity. Okay, let's go to example 3. Two more. So for example 3, we have the same base, so that should be easy to do. Okay. So A is what? What's the number in front? What's the base of the exponent? Let's start with that. 3. Is there a number that's being multiplied by 3 in the front? 1. Sorry, I didn't hear you. And what's H? 0. What's K? 1. So we already have our table for Y equals 3 to the X because we use that same table. So I'm just going to rewrite those numbers. All right, and this time we're adding 0 to H, so that means that my domain, those numbers aren't going to change. And for my Y value, I'm multiplying it by A and adding K. So I'm multiplying it by 1 and adding 1. So essentially, you're just adding 1. So let's go ahead and make our table. And this should go pretty fast because our X's, are not changing. And our Y values are going up by 1. So that would be 1.3, 2, 4, 10, and 28. And obviously that last number won't fit, and that's okay. The last order pair we'll have to just leave it off. Fit what you can fit. Now, before I plot my points, I do want to fill in our key information at the bottom. So our domain is negative infinity to infinity. And you can look at our y values and tell that the numbers are increasing. Okay, so k is 1 and it's going up. You have a horizontal asymptote at y equals 1. So I always like to draw that in. I usually do red. Go ahead and plot that blue table and connect your graph, and you are done. All right, any questions about example 3? All right, last one. Let's go to example 4. So for example 4, again, I like to always write out my A, B, H, K. So this one can be a little tricky because you may think that the base is -2. The base has to be positive. The base is actually 2. The reason why it says -2 is because A is -1. So my base is 2, my A is -1. What is H?
0.
And what's K?
8.
8. So I'm going to draw in my horizontal asymptote at y equals 8. And we use a base 2 on example 1, so we don't have to recreate that table because we already have that. So y equals 2 to the x. We already did that table, so I'm just going to rewrite it. Again, I stick with the same y value, the same 5x values. So it's 2 to the power of -1, 2 to the power of 0, 2 to the first, 2 to the second, 2 to the third. So you can flip back to example 1 if you don't remember. And then you're applying your transformations. It's always h plus x. So again, we lucked out because only half of my table is going to change. Because when you add 0 to x, those numbers don't change. And then you're multiplying your y values by a and adding k. So you're multiplying it by multiplying it by -1 and adding 8. So take a minute and get your table. Again, I already know that half of the table is going to stay the same. And now pick up your calculator, take 0.5 times -1 plus 8. 1 times -1 plus 8, 2 times -1 plus 8, etc., and plot your points. Your quiz is going to be Thursday. I'll update Canvas as soon as possible. My first period took a vote and they said they wanted their quiz review today because I was going to pass it out Monday. But they said they wanted it today. But I want you to focus on homework and then start going through your review. I haven't posted the answer key to the, well, actually, no, it might be posted, the answers to the quiz review. They might be posted, actually. I'll check. Okay, so let's see. I'm going to start at the bottom. Okay, 8 times -1. Okay, so this is 0. 4 times -1 is -4. -4 plus 8 is 4. -2 plus 8 is 6. -1 plus 8 is 7. 7.5. All right, so let's go ahead and plot these points. So all of these points are under the asymptote. So what is our domain? -infinity to infinity. So this is our first time where we had a negative a value. And when we look at our points, notice that if we look at your table, notice how the numbers are getting smaller. So in this example, it's coming from -infinity because we have an arrow pointing down. So it's -infinity. And then the highest it's going to reach is -8. Not -8, sorry. +8, except it'll never be 8, which is why we keep it in a parentheses. So this is the first half of 5.3. And now let's talk about the second half of 5.3. Even though I'm not going to be here on Friday, you still have an assignment, and this is the first time that the assignment is graded. So I'm going to talk about that now.